Welcome to part 3 of 3.4 exponential and log equations. This is the last part we're going to go over. Our central question is the same. How can we model a real-life situation with a log equation? So there's a property called the one-on-one property of logs to solve log equations. So express the equation in the form you have log sub bm equals log sub bn. This form involves a single log whose coefficient is 1 on each side of the equation. So use the one-on-one property to rewrite it. So if you have that, then m equals n. Solve for your variable. You're going to check your proposed solutions again, just like we did last time. So let's work on this problem. We need to make sure we have it set up in the correct way. So you want to set it so condense your logs first. So that means we're going to have put this back so it's division. Now you have it set up where you have no coefficients and yet you have them equal to each other. So this means that x minus 3 is going to equal 7x minus 23 over x plus 1. Multiply both sides by x plus 1. We're going to combine all like terms on our left side, so we'll set the right side equal to 0. So you should end up with x squared minus 9x plus 20 equals 0. So we'll use our just factoring ways, and you should get x minus 5 and x minus 4. So we have x equals 5 and x equals 4. We need to go and check these now. So we're going to check 5. So we're going to plug 5 in for our x and see what happens. So now we're going to do our division again, so combine or condense. So 5 checks out. We still need to check 4 to make sure that one works as well. So we're going to do the same thing, we just have different numbers. So 4 checks out. So your solution set is 5 and 4. Make sure you check. Sometimes it does work. In this case it worked, but in the last one before this it didn't work. Next part we're going to talk about is application. How does knowing how to do this actually help you? So think about money. How long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest if it's compounded quarterly? So we have our equation. This is the equation we had learned before. And we're compounding it quarterly. And we're looking for our exponent. Divide both sides by your 1,000. Now we're stuck in a situation where we need to use our logs or natural logs. Since I have an exponent here, it goes out front. In order to get t alone, I need to divide by 4, and I need to divide by my ln 1.02. And that's going to be about 16.2. If you put that in a calculator, it would be about 16.2. So after 16.2 years is your answer. So in this case, you're looking for your exponent. So in order to solve for that, you need to be able to use your logs. Here's a different example where you have to use it. So the percentage of adult height attained by a girl who is x years old can be modeled by f of x equals 62 plus 35 times log x minus 4, where x represents the girl's age from 5 to 15, and f of x represents the percent of her adult height. So at what age has a girl attained 97% of her adult height? So we're going to plug in 97, because that's our percentage. We have 62 plus 35 log x minus 4, because we're looking for our x. So now we're going to subtract 62 from both sides, so I should get 35 equals 35 log x minus 4. Divide both sides by 35 because that's what's in front of my log, so I'll end up with 1 equals log x minus 4. So this is 10 to the 1 equals x minus 4. So at about 14 years old, she will have her 97% of her adult height. So make sure you complete the questions below and you work on the homework, and I will see you in live class.